Hello everyone, welcome back. In today's video, we are going to start with another important data type in Python, that is strings. As bioinformaticians, we actually work with strings every single day. We just call them DNA sequences, gene IDs, or protein names. What is a string? A string is simply a sequence of characters written inside quotation marks. In Python, you can use either single quotes or double quotes. Both will work and they behave the same. So, ATGCGTTAAC within single quotes and ATGCGTTAAC within double quotes are both valid strings. DNA sequences, gene names, and even species names are all just strings. Why are strings important in bioinformatics? Strings are everywhere in bioinformatics. Your DNA and RNA sequences are strings. Protein sequences are also strings. Gene names, IDs, even the paths to your FASTA files are just strings in Python. So being comfortable with strings is absolutely essential for writing even the simplest bioinformatics scripts. This is why this video will be a little bit longer because there are a lot of things to cover about strings as strings are the backbone of bioinformatics. I would advise you to stick through the complete video to get a clear understanding on the string data type. String indexing means that each character in a string has an index associated with it. Let's say our DNA sequence is ATGCG. The first character A has index 0, the second character T has index 1, G has index 2, C has index 3, and the last character G has index 4. Now if we count from the right side, the last character G becomes -1, C becomes -2, G becomes -3, then T is -4, and the A at the beginning is -5. So positive indexes count from the left and negative indexes count backwards from the right. Let's talk about string slicing. String slicing simply refers to fetching a substring from a string. The basic syntax is string, then within square brackets we write the starting index followed by the ending index and then the step value, all separated by a colon. The start index tells Python where to begin, the end index tells it where to stop, and the step controls how many characters Python moves at a time. In most normal situations, we don't need the step value and we simply use the syntax string, and within square brackets we give the starting index followed by the ending index separated by a colon. Like DNA, and within square brackets I write 0:3. This will extract the first codon. Then DNA within square brackets 3:6 would give the second codon. If we write DNA and within square brackets we just write colon and 4, Python starts from the beginning. And if we write DNA and within square brackets we write 4 and colon, Python goes all the way to the end. Now if we want to skip characters, we can use the step parameter. For example, DNA and within square brackets we write 0:7:2 starts at index 0 and then jumps 2 characters at a time. So we get every second base in the sequence. We will see all these examples in details later while coding in our Jupyter notebook. Reversing a string using slicing. Just like with slicing, we can use the step value to control the direction. A step of -1 simply means go backwards one character at a time. So when we write DNA ::-1 within the square brackets, we are telling Python to start from the end of the string and move backwards, effectively reversing the entire sequence. We will be reversing a DNA sequence later in our Jupyter notebook, and there you will understand it more clearly. String concatenation. In bioinformatics, we often work with short fragments like codons or small sequence reads. Sometimes we want to put them together into longer sequence. In Python, we can do this using the plus operator. For example, in the slide you can see ATG plus CGT. This combines the string ATG and CGT and produces one longer string, that is ATGCGT, which is a longer DNA sequence. Now, can we add numbers to strings? Something very important to remember is that Python will only concatenate strings with other strings. If you try to add a number to a string, Python does not translate it automatically. Take the example shown in the slide. ATG plus 5. This will cause a type error because Python has no idea how to add a DNA sequence to an integer. So before adding a number to a string, we need to convert the number into a string first. Finding the length of a string. The length function tells us how long a string is. For example, you might want to process only sequences that are at least 30 bases long, and you could check that using the length function. Now that we have learned the concepts on the slides, let's switch to Jupyter Notebook and actually try each concept step by step using Python code. First, let me write the heading as defining a string. In Python, strings are defined using either single or double quotes. Here I am creating a variable called DNA underscore sequence underscore 1 and assigning it the value ATGCGTTAAC. This is our example DNA sequence. An important thing to note here is that the DNA sequence is written within single quotes, which makes it a string. Then, by writing print DNA underscore sequence underscore 1, prints the exact sequence that we stored in the variable. Then I'm writing print, and within the round brackets I'm making the use of the type function here, and then again I pass DNA underscore sequence underscore 1 to the type function. The type function tells us what kind of data we have stored. In the output we see class str, which simply means that this is a string. Instead of single quotes, we can also use double quotes and it won't make any difference. Let's take a look at another example. Here I am updating the value of the variable DNA underscore sequence underscore 1 by another DNA sequence. But this time I am writing the DNA sequence within double quotes. And then I am printing the value of the variable DNA underscore sequence underscore 1. And then again printing its type on the next line. And in the output we see our new DNA sequence and the type is string. Let's take a look at what happens when we don't write our DNA sequences within single or double quotes. Here I am again updating the value of variable DNA underscore sequence underscore 1 by another DNA sequence, but this time I am not adding any quotes. And then I am printing the variable and its type as usual. But as soon as I run it, Python gives us an error. Name followed by our DNA sequence is not defined on line DNA underscore sequence underscore 1 equals to our DNA sequence. For now, just understand that this error means that Python is not able to recognize our DNA sequence as a string. And since we got an error, therefore the following two lines where we were printing the variable and its type did not get executed. Therefore, whenever you are working with strings in Python, make sure they are written within single or double quotes. Then next I am creating another variable called gene underscore name and assigning it the value BRCA1. Then I am writing print and within round brackets I am passing the variable gene underscore name. and then I'm writing print type gene underscore name. This will simply show BRCA1 on the screen and its type as string. Now let me first write down the heading as string indexing. Now by writing DNA underscore sequence underscore 2 equals to TTAGGC, I have created a new string variable called DNA underscore sequence underscore 2 and assigned it the value TTAGGC. In the next line, I write first underscore base equals to DNA underscore sequence underscore 2 and then inside square brackets I am writing 0. So DNA underscore sequence underscore 2 and 0 within square brackets is supposed to return the character at index 0 in the string. Or we can say it is supposed to return the first base from a string. Therefore it returns t, since t is the first base and it has an index of 0. And this gets stored in the variable first underscore base. Then similarly, by writing second underscore base equals to DNA underscore sequence underscore 2 and then 1 inside the square brackets, I am trying to fetch the second base or the base at index 1 from our string DNA underscore sequence underscore 2 and therefore it returns G and it gets stored inside the variable second underscore base. Next I write last underscore base equals to DNA underscore sequence underscore 2, but this time within square brackets I am writing -1. Here I am making use of negative indexing which starts from -1 and from the right. Therefore by writing -1 within square brackets I am trying to fetch the last base from our DNA sequence. Therefore DNA underscore sequence underscore 2 and -1 within square brackets returns the last character from a string, that is C, and it gets stored in the variable last underscore base. Then similarly I write second underscore last equals to DNA underscore sequence underscore 2 and within square brackets I write -2 to fetch the second last base from our DNA sequence, and it returns the second last base, that is G, and this gets stored in the variable second underscore last. Now I write print first underscore base print second underscore base print last underscore base and print second underscore last. For printing the value stored inside each of these variables, and we see the output as T, G, C, G respectively. We can also modify our print statements to make the output easy to understand. So now I write print first base in our DNA sequence is within double quotes, then I put a comma and write the variable name. Similarly, I do this for the rest of the three variables. By writing this way, we can print any message along with the value of our variables. And now you can see the output is more detailed and easy to understand. Now let me first write the heading as string slicing. Here I am creating a variable named as DNA underscore sequence underscore 3 and storing the sequence ACGTAGC in it. This time the string is ACGTAGC. Now on the next line I am creating a new variable called first underscore 3. Here I am using slicing and I write DNA underscore sequence underscore 3 and within square brackets I write 0 colon 3. That means I am taking characters starting from position 0 up to index 3 but not including index 3. So basically I am grabbing the first 3 letters of the sequence and printing first underscore 3 variable shows the first 3 bases that are A, C, G. Then I am creating another variable called next underscore 3. This time I am slicing from index 3 up to 6. So it takes the 4th, 5th and 6th letters from the DNA sequence and printing next underscore 3 variable shows the next 3 bases that are T, A and G. Next I am writing from start equals to DNA underscore sequence underscore 3 and within square brackets I just write colon and 4. Notice, here I didn't put a starting index. That means Python will automatically start from the very beginning and go up to index 4, but not including it. So I'm basically collecting the first 4 letters of the sequence and printing from underscore start variable shows the first 4 bases that are A, C, G and T. After that, I am writing 2 underscore end equals to DNA underscore sequence underscore 3 and within square brackets I write 4 and colon. This is the opposite of the previous one. Here I gave a starting index but I didn't give any ending index. So Python will start from the 5th base and go all the way to the end of the sequence. And printing 2 underscore end variable shows everything from the 5th base to the end that are bases A, G and C. Then I write entire underscore sequence equals to DNA underscore sequence underscore 3 and within square brackets I just write a colon. When you slice like this without giving any start or end, Python just returns the entire string. So here I basically duplicated the whole DNA sequence and printing entire underscore sequence shows entire DNA sequence because here we are not specifying the starting and the ending. Now let's see how step values work. Here I'm starting with the DNA sequence again. DNA underscore sequence underscore 3 equals to ACG TAGC. So this is just a string with 7 characters A, C, G, T, A, G and C. Now here I'm writing every underscore second underscore base equals to DNA underscore sequence underscore 3 and within square brackets I write 0 colon 7 colon 2. So what's happening here? I'm slicing from index 0 up to but not including index 7 and I've added a step value of 2. That means I'm not taking every single character but I'm skipping one each time. So I'm collecting every second base from the DNA sequence. Now I want to see what these slices actually look like. Here I'm writing print every underscore second underscore base. This will print out all the characters we picked with step equals to 2. Next, Here I am writing reverse underscore every underscore second equals to DNA underscore sequence underscore 3, and within the square brackets I am writing colon colon minus 2. This one is interesting. The minus 2 means I am going in reverse order and I am also skipping one character each time. So basically I am starting from the end of the string and picking every second character backwards. So we get every second base in reverse order. And here I am writing print reverse underscore every underscore second. This will show the characters we got when we sliced backwards with step equals to minus 2, and the output will be CAGA. So with these two examples I am showing how the step value works in Python slicing. Positive step moves forward skipping characters and negative step moves backward skipping characters. Next, I simply write print DNA underscore sequence underscore 3, and within square brackets I write colon colon 1. And we see our entire DNA sequence in the output. This means that if we keep the step value as 1 and don't specify the start and end index, then we get our entire DNA sequence printed. This is the same as writing DNA underscore sequence underscore 3, and within square brackets we just write 2 colons, because by default Python takes the step value as 1. Another important thing to notice is that earlier when we just wrote DNA underscore sequence underscore 3 and within square brackets we just wrote a colon, it also gave us our entire DNA sequence. Because here also Python takes the step value as 1 even when we don't add another colon in the syntax. This is because the step value parameter is optional and Python doesn't throw an error even if we don't specify it. Now we will see how we can reverse a DNA sequence. Here I am creating the variable DNA underscore sequence underscore 4 and assigned it the value GATTACA. Then I write reversed underscore sequence equals to DNA underscore sequence underscore 4, and within square brackets I write colon colon minus 1. By using colon colon minus 1, Python reads the string from the end to the beginning one character at a time because the step value is minus 1, and the reverse string gets stored in the variable reversed underscore sequence. On printing the variable reversed underscore sequence, we see the output as ACATTAG, which is simply the original sequence reversed. Now if we simply want to print the reversed DNA sequence without storing it in any variable, we can just write print, and within round brackets we can write DNA underscore sequence underscore 4 and colon colon minus 1 inside square brackets, and it will print the reversed DNA sequence for us. Now let me add a heading as string concatenation. Here I am creating a variable called DNA underscore sequence underscore 5 equals to ATG. So this is my first DNA sequence, a string with 3 letters A, T and G. Next I am writing DNA underscore sequence underscore 6 equals to CGT. This is my second DNA sequence, another string with 3 letters C, G and T. Now here I am combining these two sequences. Combine underscore sequence equals to DNA underscore sequence underscore 5 plus DNA underscore sequence underscore 6. What I am doing here is using the plus sign to join the two strings together. So DNA underscore sequence underscore 5, which is ATG, will be joined with DNA underscore sequence underscore 6, which is CGT. Here I am writing print combined underscore sequence. This will print the result of the concatenation, which is ATGCGT. Next, here I am directly combining two string values without variables. Combined underscore sequence underscore 2 equals to ATGC plus CCCC. So I'm joining the strings ATGC with the string CCCC. And here I'm writing print combined underscore sequence underscore 2. This will print ATGC CCCC. So with these examples, I've shown how the plus operator in Python can be used to concatenate or join two strings together. Let me add a heading as adding strings to integer or vice versa. Now here is something that beginners often try, that is adding a number directly to a string. Here I am writing result equals to DNA underscore sequence underscore 5 plus 5. Now what I'm trying to do here is add the string DNA underscore sequence underscore 5, which contains the bases A, T and G with the number 5. But here's the problem. In Python, strings and numbers are two completely different data types. The plus sign can join two strings together, or it can add two numbers together. But it cannot mix a string and a number. So when I run this line, Python will throw an error and it says type error, can only concatenate str not int to str. That's Python way of telling me, hey, you tried to add a string and an integer, but I don't know how to do that. So the important point here is, if I want to join a number with a string, I need to first convert that number into a string using str function. Otherwise, this kind of code will always give me an error. Here I am writing result equals to DNA underscore sequence underscore 5 plus str5. What I did here is I used the str function to convert the number 5 into a string 5. Now although 5 looks like an integer, but since it is inside double quotes, it is considered as a string. So an important point to remember here is that any number, whether an integer or float, if it is written within single or double quotes, it becomes a string. Basically, any character within single or double quotes is a string, no matter if it looks or feels like some other data type. So now I'm joining two strings ATG and 5. Next, I'm writing print result, and this prints ATG5. So the key idea here is, if you ever want to join a number with a string in Python, you have to convert the number into a string first. Now I am writing the heading as length of a string. Then I'm creating a new variable DNA underscore sequence underscore 7 equals to AAGCTT. So this is my DNA sequence and it has 6 letters A, G, C, T and T. Next, here I'm writing sequence underscore length equals to length DNA underscore sequence underscore 7. What I'm doing here is using Python's built-in len function. Len simply counts how many characters are inside a string. So in this case, it will give me the total number of bases that are there in my DNA sequence. Now here I am writing print sequence underscore length. This will print the number of bases in the DNA sequence, which is 6. We can also directly print the length of a DNA sequence just by typing print, and within round brackets I make use of the length function, and then I pass DNA underscore sequence underscore 7 inside the length function. This way we can print the length of any string variable without having the need to first store the length in any other variable. Or we can also pass a raw DNA sequence inside the length function as follows. Print len, and then within double quotes I am writing ATGACATA. Here I have just passed the random DNA sequence directly into the length function without even storing this DNA sequence in any variable. So overall I have just shown how you can quickly find the length of a DNA sequence or any string using the length function. Great! In this video, we learned the basics of strings in Python using bioinformatics related examples. We looked at what strings are and why they are important. We explored how indexing works, including negative indexing. We practiced slicing and saw how the step value can change the way we extract parts of a string. We also looked at how to reverse a string. Then we combined multiple strings together using concatenation. We checked what happens if you try to add a number to a string. And finally, we used the length function to find the length of a sequence. So these were the key concepts about strings that will help us when working with DNA or gene data in Python. These are foundational skills and will be used again and again in your bioinformatics journey. So that's it for today's video. We covered the basics of strings in Python with some cool bioinformatics examples. I hope this made things simple and easy to follow. If you found this helpful, don't forget to like the video, share it with your friends, and of course, subscribe to the channel so you don't miss any future lessons. Thank you so much for watching, and I'll see you in the next one.